We are still in 1.1, section that never ends. Right now, we will be looking at the operations of functions. Simple enough section. To operate on functions, you need to have at least two functions. So let's have an f of x is equals to x squared plus 2x plus 3, and then let's have a g of x, which is equals to 3x minus 4. Very simply, there are four operations. The addition operation, you just put a plus sign between the two functions. The subtraction, put a minus sign between the two functions, f minus g. The of x, multiplication function, put a dot, f times g of x. And then we have your division, f divided by g of x. And your division function has a special rule in that the denominator function, g of x, cannot be 0. Of course, that is because we cannot divide by 0. What we will do is we will find each of these functions and then find the domain. So f plus g is simply x squared plus 2x plus 3, your f function, plus your g function, 3x minus 4. That simplifies to x squared plus 2x plus 3 plus 3x minus 4. And then we group like terms. That is, I hope, x squared plus 5x minus 1. There you go, f of g of x. Your domain right here, this is a polynomial function, and so your domain is simply all real numbers. Lots of fun, lots of fun. All reals. That's the first one. F minus g is x squared plus 2x plus 3 minus g, 3x minus 4. In this case right here, to get through the parentheses on the second one, it's a little bit more difficult. You have to distribute that minus sign. And so you would get x squared plus 2x plus 3 minus 3x plus 4. I am subtracting all of g, so the whole of g needs to switch signs. And then, of course, I group like terms. And so that's x squared minus x plus 7. F times g of x. Again, it's pretty straightforward. Oh, the domain again, this is just a polynomial. The domain again is simply all real numbers. F times g of x, you're simply multiplying them together. X squared plus 2x plus 3 times 3x minus 4. And this is where well, you can FOIL, multiply every term by every term. But this is where one of those other techniques that I showed you earlier comes in handy. I'm multiplying x squared plus 2x plus 3 times 3x minus 4, and you just fill in the correct products. So for example, x squared times 3x gives us 3x cubed. Then the next term would be 6x squared plus 9x multiplied by negative 4. That will give us negative 4x squared, then minus 8x minus 12. And then if you look very carefully, you'll notice that these two are, these two are like terms, and that and these two are like terms. And so my answer would be after grouping like terms, it will be 3x squared. 6x squared minus 4x is plus 2x squared. 9 minus 8 is just 1x, and then minus 12. That's my answer. And of course, my domain here is all real numbers. Let's give it a set bullet this time. All real numbers. Or if you prefer, x such that x is an element of the real number system. The best system that, well, actually, we have better systems like, complex numbers, fancy stuff like that. The last one is to, of course, divide. And so I will have f divided by g. You can actually write it this way as well. And that will be x squared plus 2x plus 3 divided by 3x minus 4. Normally, you would attempt to factor the top and see if you have any factors that cancel out. But none of them do. And so therefore, this actually is your answer. However, the domain is more complicated because I have to set the denominator not equal to 0. That's 3x minus 4. That cannot be 0. And so therefore 3x cannot be 4. Therefore x cannot be 4/3. The domain in set builder, x such that x cannot be 4/3. I'll skip the graph. And then your interval notation will be negative infinity to 4/3. Open circle at 4/3. Open circle at 4/3. And then you go until you reach infinity and beyond. Now, this was pretty easy, right? Let's do all of this again, but with fractions. Yay! So let's say I have f of x is equals to 1 over x plus 2, and g of x is equals to x over x minus 1. And let's go ahead and add f plus g, 1 over x plus 2 plus x over x minus 1. To add fractions, you need to have a common denominator. And so I will multiply this one by x plus 2 over x plus 2. And I will multiply this one by x minus 1 over x minus 1. The common denominator is the product of the two denominators. And so that will leave me with, when you multiply these, you get x minus 1. When you multiply these, you get x squared plus 2x. And your denominator is x plus 2 times x minus 1. Of course, I simplify by grouping like terms. And that leaves me with x squared plus 3x minus 1 over x plus 2. That does not look like a 2. Over x minus 1. My domain here will be that x such that x cannot equal negative 2, x cannot equal 1. That would be my domain right there. Okay, let's add in the two functions again. Again, you'd attempt, well, actually no, that's your domain right there. F minus g. And f minus g right here is the same work. The difference is you have a subtraction sign between them. And so what you would have is 1 over x plus 2 plus x over x minus 1 multiplied by x plus 2 multiplied by x plus 2. We're trying to get a common denominator. X minus 1, x minus 1. Oh, I have the wrong sign. I should be. Oh, there you go. Subtracting. So that will leave me with x minus 1 minus x times x plus 2 over x plus 2 x minus 1. I distribute the negative x, and that will leave me with x minus 1 minus x squared minus 2x over my denominator. And of course, I simply group like terms. And so that will leave me with negative x squared minus x minus 1 over x plus 2 x minus 1. And again, I have the same domain. X such that x cannot equal negative 2, x cannot equal 1. Go ahead and see if you can give that domain in interval notation as well. So far so good, right? What about multiplying them together? F times g. F times g of x is the product, so you just put them next to each other. 1 over x plus 2 times x over x minus 1. And of course, you just multiply across. 1 times x is x. And then the denominators, you just don't FOIL them out. You just put them next to each other. And of course, again, I get the same domain. X such that x cannot equal negative 2, x cannot equal 1. Woo! Hard work and sacrifice. That's cool, that's cool. The last one, the division, f divided by g of x is simply f divided by g. And of course, remember to keep it, change it, flip it. You keep the first term unchanged. And instead of dividing, you multiply it by the flipped denominator. And of course, as you have it, life's pretty good. So you just multiply across again. That leaves us with x minus 1, multiply across in the denominator. And this right here, you have x plus 2. Right here. Now, you have to be a little bit careful when you're trying to find the denominator here. You have to remember the basic rules. The domain for your function, first and foremost, comes from the domain of the original two functions. The original two functions was x plus 2 and x minus 1 in the denominator. And so your domain would be the same, x, such that x cannot be equal to negative 2 and x cannot be equal to 1. But now, you notice right here, I have an extra x in the denominator. And that gives us the third criteria, that x cannot be 0. As if x is 0, the denominator will be 0. And of course, that's bad. And thus ends our tale.